In this video, we're going to go on to look at example number 4 of integration by substitution. And here we have the integral of the square root of 2x minus 1 dx. And I'm first going to rewrite that as 2x minus 1 to the 1/2 power. And we can definitely see that we have function composition here. 2x minus 1 is the inside function. Now the derivative of 2x minus 1 is just 2. And since that is a constant, then integration by substitution is always going to work. So whenever the derivative of the inside function is a constant, it is integration by substitution will always work. Another way of stating it is that if the inside function is a linear function, then integration by substitution will always work. So we let u equal the inside function, which is 2x minus 1. The derivative of u with respect to x is 2. The differential is du is equal to 2 dx. We only have a dx in the original that we want to swap out for. And so we divide both sides by 2, and we get 1/2 du is equivalent to dx. So that's what we'll swap out for dx, and the 2x minus 1 is u, and so we get 1/2 integral u to the 1/2 du. So that 1/2 from the 1/2 du comes all the way out, and we get 1/2 integral u to the 1/2 du, which we can then integrate. U to the 1/2 becomes u to the 3/2 over 3/2, or 2/3. So we have the original 1/2 times 2/3 times u to the 3/2 plus c. Swapping out the u, we get 2x minus 1 to the 3/2 divided by 3 plus c. Okay, so then what we learned in this particular example is that if the inside function is a linear function, or stated another way, if its derivative is a constant, then integration by substitution always works. Okay, so I put an integral out here for you to try. That would be integral of x to the 3rd times the square root of x to the 4th plus 2 dx. And you can pause the video, work on that, and then I will give you the solution to that in a few seconds. Okay, so the answer to that would be 1/6 of x to the 4th plus 2 quantity to the 3/2 power plus c. And if you got that, then you can just go on to the next video. Otherwise, I will work through that here. Okay, in solving this problem, first thing I'm going to do is rewrite. And in rewriting, we can see that we have function composition. The inside function is x to the 4th plus 2. The derivative of that would be 4x to the 3rd, and since that's a constant multiple of the x to the 3rd on the outside, then integration by substitution is going to work. We'll let u equal x to the 4th plus 2, the inside function. We take the derivative and write it in differential form, so that's 4x to the 3rd dx. And since we only have an x to the 3rd and dx to swap out, we want to divide both sides by 4. And so we swap out x to the 3rd dx for 1/4 du. We swap out x to the 4th plus 2 for u. And we're ready to rewrite, bringing the 1/4 all the way out. We simply get 1/4 integral of u to the 1/2 du. And we're ready to integrate that now. Integrating u to the 1/2, we get u to the 3/2 over 3/2, or 2/3 u to the 3/2 plus c. We have the 1/4 out there already, so we're going to simplify that. We get 2/12, which is 1/6. Swapping out the u for x to the 4th plus 2, and that's to the 3/2 power plus c, and we get the desired result above. Alright, so we'll go on to another example in the next video.